Hey, what's up, guys? This is Chung here. So this time, LeetCode number 1883. Minimum skips to arrive at meeting on time. So this one, the description is pretty long, right? And basically, you're given like an integer hours before, right? And that's our target, basically. So this hours before means that that's the total, that's the maximum traveling time we can use. Right? And then to arrive at the meeting, we have to travel through n roads. And so each road has its own distance. Okay. And then you're also given like a speed, right? Which speed is like the kilometers per hour you will travel. And here, we're traveling from the first road to the last road. Okay. And after you travel the road I, you must rest and wait for the next integer hour before you can begin traveling on the next road. Right. So for example, right, if traveling a road takes 1.4 hours, so we must wait until the 2 hours mark before traveling to the next road. Right. If the traveling road takes exactly 2 hours, then we can immediately start to travel to the next one. But then you're also given like another option here. You can also choose to skip the skip the wait. So which means that for example, this one, right? So after traveling the the previous road or current road takes 1.4 hours, and this time we don't need to wait. We can just immediately start the traveling to the on the next road. Okay, but our goal is that we return the minimum number of skips required, so that we can so still we can meet this hours before, right? If it's not possible, return -1. Right. So obviously, we can always skip, right? But the more we skip, the more numbers of skips required it will be, right? But our goal is to try to minimize that. Basically, we try to skip as minimum as possible, while still can meet this hours before target, right? I know this description is pretty long here, right? So for example, right, we have this kind of three rows. So their distance is 1, 3, and 2, and the speed is 4. And our total time we want to beat is like 2 hours, right? So in this case, right, I mean, if we don't skip any rest, right? So the total time we will take is that the first road will take 0.25 hours, right? Then we have to wait until the 1 hour mark, and then we can start the second one, right? And the second one we also take 1 hour, and the last one is like 2.4, because for the last one, we don't have to wait anymore because we have already reached the traveled all roads, right? That's why the output is 1, because we can skip we can skip the you can skip between the second and the third road, and we can still, so that we can travel all the roads within this 2 hour mark, right? So basically, if we skip the second one, well, actually, yeah. So in this example, actually, it skips the between the first one and second one. Yeah, actually, yeah, you're right. So after skipping the first one and the second one, right? I mean, so we'll have like 0.25 plus 0.75, and then we'll have number one, and then plus this 0.5, right? That's why we can finish all the roads in within 1.5 hours. Okay, and so this is example 2 here, right? I mean, so in this case, we need to skip 2 rests so that we can travel all the roads within 10 hours. Okay, and so on and so forth. But for this one, no, this one we return -1 because even though we skip all the rest, since we have a pretty slow speed, we still cannot travel all the roads within this hours limit. And here are some constraints, right? So we have n is 1000, right? And then the speed, distinct, and hours before, they're pretty big. Okay, so that's the problem, right? I mean, obviously, no, we have 3 things we have to consider. So the first one is the current is the index. We have I. So I means that we are at ith road, right? And second one is what? Second one is j, right? So we have j. J means that uh, j is the skip times, right? So this is the second thing. Basically, how many times we have skipped while standing on the ith road, right? And the last one is what is k is I have k. K is that the minimum, right? Minimum hours spent, right? So this is the minimum, not hour. Okay, so yeah, we can say it hours. So basically, these are the 3 things that we need to take into consideration, right? Because again, right, we have to make sure the total hours we use is within this range, right? And we also want to minimize this thing. And this I is obviously is also like required because we want to know, like, since we are traveling from the starting to the end, that's why we need to know, okay, so which road are we traveling right now, right? Then we can decide if we want to skip the rest or not. So with these 3 things, we can have like several maybe 2 different DP definition option here, right? um, for example, we can have like DP I and K and then equals to J, or we can have like DP IJ equals to K, right? I believe both of them will work, but if you look at the constraints here, so I and J, they're both within the range of 1000, right? Because obviously the maximum number we can skip is also like 1000, right? But K here, the minimum hour spent, remember, since we'll do like a multi division here, basically this K will be a float type, right? And with this kind of speed and float type, this case will be pretty big, right? So which means if we choose the first one, this is 1000, right? But this one could be maybe 10 to the power of 7 or even 9, we don't know based on the precision of the float. And this one, I think this one will TLE, right? So, that only leave us one condition here, which is the one option, sorry, which is the DPI and J, where the first one is that we are standing on the ith road, and we have skipped J j rest, and the value of this dp means that no, that's the minimum. What's the minimum hours we have already spent, right? And with this thing here, right? So with this thing here, once we have that, so how can we use this like dp state dp array to find the final answer? Basically, we simply just check the dp -1, right? So dp -1, which means that we have traveled all the roads, right? And then we check the values, since we could have like different skips, right? Obviously, the more skip we use, the smaller the k will be, right? So we just list loop through from 0 to n minus 1, right? So the first one the first k that is either equal or smaller than ours before, and this skip will be our final answer. Right, since we're getting the smallest, right? We're trying to get the minimum. Okay, so, and with that being said, right? So now we have a dpi and j equals to k. How can we what's going to be the state transition function here, right? So we have dpi j, right, equals to k. So dpij means that what's going to be we're standing on the ith road, and we have skipped j. We have skipped j times, right? So since we're doing this this time, we're doing the bottom up, which means that we need to know what are the states can get to the current one, right? So the previous state can be what? So the previous state, we only have two options. Basically, we're standing on this I road, right? And the previous one is I minus 1. From I minus 1 to I, we only have two options, right? So we either skip this rest. So this is a rest, right? In between. So we either skip this one or we don't skip this one, right? So I think the easier one is that if we skip, if we skip this one, I don't know if it's easier or not. So if, let's say the first one is if we skip this rest, so what do we have? We'll have dp. So if after skipping this rest we get to the current state, then it's going to be a dp of always I minus 1, and then what? If we skip this one, right? So which means that the skip time will be increasing by 1, which means that the previous state will be j minus 1, right? Because currently we have j. So if the previous option is skip, then the j should be will be increased by 1, which means that the previous state will be j minus 1, right? So if we skip that, right? If we skip that, and then the time, right? So the time we spend for the current one will be the dp. Will be the distance, right? Distance of I, right? I mean, it could be I minus 1 because the current distance. So let's say this one is a distance here, right? So I'll just not use this one. Plus d, right? So this one means that if we don't skip, sorry, if we skip this one skip, sorry, because this means that whatever previously value we have, right, we'll just since we skip the rest, we'll just use that to plus the current distance divided by the speed, right? So that's the first one, and second one is not skip, right? So if we don't skip, so if we don't skip, it means that after the previous I minus 1 row, we have to wait until the next integer hours, right? Which means that, we have to do a ceiling of the previous value, right? It's going to be a ceiling of what? Of dp I minus 1, of course, right? But this time is what? It's j. Why is that? Because we don't skip, which means that we didn't skip, which means that the j didn't change. That's why the previous state is still the j. J skips, right? Right, so we do a ceiling here, and then again, right, we do this one, the speed, right? So that's the two options, right? That's the two options to get to the current state. Yeah, and here's our state transition function here, right? And we just need to get the minimum of skip and not skip, right? Because we're trying to minimize the hours we use, right? At each state, so that we can use the if we minimize that, basically if we minimize the time we use at each state here, and then we can use this data, right, to get the basically to get the minimum skips we can skip, where we can use, so that we can still meet the hours before. Okay. And yeah, I think that's it, right? I mean, let's start coding. And actually, during the code, there's like a little a tricky part we also need to be careful. I'll just start coding first. So at the beginning, we have dp, right? Since it's like a two-dimensional dp, and since we're storing the minimum values inside dp, that's why I initialize everything with the max size, right? And then for this thing in range n+1, I believe you can also do n here, but I use n+1 so that I don't have to worry about the I-1 or n-1. Right, so at the beginning we have dp0 and 0 equal to 0. That's the base case, right? Which means that if we have zero rows and we have zero uh, skips, actually zero. Actually, everything with 0, they should always all be 0, right? Yeah, I guess we can do something like this. So since I think this one doesn't really matter as long as we set this dp this first one to 0, I think it should work. But what I'm trying to say is that um, with 0 rows, right, it doesn't really matter like how many skips we have, right? It will always be 0 because since we don't have any road, right? I mean, the hours would obviously be 0, right? And the second one is that so the reason we need to set some base case is because remember we have some dp I-1 and j-1, right? In our state transition function here, since we're defining the in a way that we have n+1 here, when we do our for loop here, we'll start from 1 instead of 0, 1 to n+1, something like this. So which means that we have to initiate 0 because we will not traverse with 0 index. That's why we're gonna set the base case beforehand. So now we have set everything for dpi, for dp0. Now it's the time for the dp I and 0, right? So for n+1, right? So for dp I and 0, so what does this one mean, right? So for dp I and 0, it means that we'll never skip. Basically, we'll never skip the make a skip. So which means it's always 0. which means we'll always do a round up for the previous value to the current one. That's why, you know, for this one, basically it's like a ceiling of the dp I minus 1, right? I minus 1, 0, and then plus the distance of I minus 1 divided by speed. So this one means that, you know, since it's 0, it means that, you know, we'll always round up, do a scaling of this, because we'll always need to wait to the next integer time mark, right? And then here it's a distinct this distance of I minus 1 because now the index is 1 based instead of 0 based, but this distance is like 0 based. That's why, you know, we need to do a I minus 1 to get to the correct distance of the current road. Okay, so now we have set both the base case. We can start our dp for loop here, right? So now we're starting from the first road, right? And for the first road, we're gonna loop through all the possible skips. Okay, it's gonna be 1 to I. So the reason being is that, you know, we're at road, you know, if we're at like the third road, so the biggest skip we can possibly have is 2, right? We have 1, 2, 3. So the biggest skip is either here or here. That's why we only need to do a stop at I minus 1, right? And here is like ij, right? This one is going to be, like I said, it's going to be the minimum of this of the not skip, the skip and not skip, right? So for skip, we already talked about that. It's going to be I minus 1, j minus 1. That's the previous state since we skipped that, right? And then we get distance of I minus 1 divided by speed, right? So that's the skip, and the not skip is like this. We have to do a ceiling, right? dp of I minus 1 j, and then we also do a plus. Well, actually, no, we can move this one out. You know? Yeah, we can move this thing out since we always need to do this plus here. Ceiling of, I think that's it, right? And then in the end, we simply do we check skips, right? Skips in the range of n. Okay. Then we check if the dp minus 1 skips, right, is either equal or smaller than the hours before, right? And then we simply return the skips. Otherwise, minus 1, right? So here we're basically dpi minus 1 means that we have traveled to the end, to travel all the roads, right? And then we try all the possible skips. Since the skips the skip range will be from 0 to n minus 1, right? That's why we check everything. The first one that's within this hours before, that will be our answer. If none of those can satisfy this condition, we return minus 1. Okay, but this one is correct, but it will fail at one of the test case. You know, they're like, oh, here. If I just submit this one, yeah. So as you guys can see, so it failed at the last test case, where we have, I think, a huge number of these numbers, like the distance, and then we have some like a pretty big like speed, right? So the reason it failed is because, you know, it's because of the float accuracy issue. Because, you know, in many languages, you know, if you accumulate if you do like a divide here, it will not keep all the precisions, right? For example, if we have like 1.4526774 6 something like this. If the precision is not high enough, right? Instead of returning everything, it would round this up to like 775. Basically, it will discard everything after it, right? Something like this. And if we do that, I mean, if we keep doing that, and here if we do a we keep doing this accumulation here, and we do a staging here, it will just accidentally increase the correct answer by 1. So that's how this division, I mean, will affect. That's why the last case failed. I couldn't go to very too much detail to that, but I think that's the reason behind it. And so the way to fix it is every time when we do a scaling here, we will subtract a small enough number to make sure, it will not accidentally go one number up. Okay. So that's why, we can define like epsilon. This is like the concept in many languages. Epsilon is we're gonna define like it's a small enough thing, right? 1e9, right? 10 to the power of -9, basically. Then every time when we do a scaling, we minus it. We minus epsilon to make sure it will basically correct that inaccuracy stuff, because we minus it, right? So which means that it will not affect our final answer, but it's big enough to correct this kind of float accuracy issue. Same thing for here, right? Same thing for here. Yeah. So basically every time we do a scaling, we have to do this thing here, right? And then now let's run again. Yeah, see, now it passed, right? And so yeah, the time complexity for this one obviously is n squared, right? N squared, because we have a nested for loop here. And another way to solve this one is that instead of doing the division, we can just convert everything into its integer format, which means that we don't division it, or we don't divide it. Instead we multiply everything with the speed, right? So basically, here will be this one, right? And this will be this one as well. And yeah, but the tricky part for this for this workaround is that how can we handle this scaling here? So what does scaling mean here? Scaling means that we will basically rounding up to the nearest integer, right? But when it comes to this kind of workarounds, basically where we multiply everything with the speed, how can we convert this thing into this format, right? So basically, what we're actually doing here is that we're trying to round this thing up, right, to the nearest like multiple like value of the speed, which means we can do something like this. We can do we plus the speed minus 1, right, and then we do like a division, a double slash division of speed, and then we times the speed back. So this is a small trick here. Basically, let's say we have like 1, 1, 2, 3 from the previous value, and the speed is like I don't know, speed is 10, something like this, right? So speed is 10. So basically, we basically we're adding 9 here. Adding 9 here, which means that we're making sure it can be greater than the next multiple of speed, but it will not affect the final answer. That's why we do we plus the speed minus 1, and then we divide it by speed. So this one will make sure it'll get the correct value we need, right? And then we multiply the speed back, since we're working on the integer version of it, not the divided version. Okay. So same thing for here, right? So when we do a staging here, we have to do the same trick here with speed plus speed and then -1, right? And then we do a speed division, and then we time speed, right? Yeah, so I think this should also work. Yeah, similar logic, but in this case, we don't need to worry about this kind of precision, float precision issues. Instead, we are working on the integer version of it, right? Yeah, I think that's it for this problem. I'll just stop here. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.